Hi. In this problem, we are going to look at a question that involves functional equations, and we are going to learn about the general techniques by which we solve problems with functional equations. So let's look at the question. Let f be a real valued function, which satisfies the relation satisfying f of x by y is equal to f of x minus f of y. And this is true for all positive x and y, right? We also have limit of x tends to 0, f of 1 plus x by x is equal to 3. G is a real valued function that satisfies the relation g of x plus y is equal to g of x plus g of y minus xy for all xy belonging to real, right? And we have limit of x tends to 0, g of x by x is equal to e square plus 6 by 2e, right? We have to find the number of roots of the equation f of x equals g of x. So that is the question. So we have two functions, f and g, which are given by these two functional equations, right? And we have to solve that somehow, get an idea of the functions, and then find the number of roots of this equation, right? So let's learn about how to solve these functional equations. So let's focus on the f function first. So what do we know about the f function? F of x by y is equal to f of x minus f of y for all positive x and y. And we also know that limit of x tends to 0, f of 1 plus x by x is equal to 3. Let's pay attention right now, first of all, to the fact that this limit is given to us, right? So if you try to put x is equal to 0 in this, you should get something like this, f of 1 by 0. But the only way in which f of 1 by 0 will give us a finite value, the only way if it will be finite is if f of 1 must be 0. Think about it. If f of 1 is not 0, it will be some constant k by 0 which will turn to infinite, right? So if they have given us the fact that limit of this expression is 3, which is a finite value, then f of 1 must be 0 and it must become 0 by 0 form, right? And only if it becomes 0 by 0 form can we find a finite limit. Also, now that we know f of 1 must be 0, we can also do L'Hopital's rule here, and we can say f dash 1 plus x by 1 limit x tends to 0 must be equal to 3. And from here, putting 0 here, we get f dash 1 is equal to 3. So just this limit tells us two pieces of information. It tells us f of 1 is equal to 0, and it also tells us f dash 1 is equal to 3, right? So that information was hidden in the limit. So you should understand why we are saying all this. Firstly, it cannot be finite if f of 1 is non-zero. Secondly, by L'Hopital's rule, it will be f dash 1 should be 3, right? Okay, so now that we have this information, what can we do here, right? So one way to handle such functional equations is to differentiate the equation with respect to x, and since x and y are independent variables, are two different variables, there is no connection that we know between the two variables. We can say that the dy by dx term, if it comes, will be 0, right? So let's do a derivative with respect to x on this equation, right? So we will get by chain rule f dash x by y and then derivative of x by y. Derivative of x by y will be by quotient rule 1 into y minus x into dy by dx divided by y squared, right, is equal to f dash x minus f dash y, and by chain rule dy by dx, right? F dash x, we don't put dx, dy by dx because that will be 1. The derivative of x with respect to dx will be 1 only. So this is the expression upon a simple differentiation. But now we realize that dy by dx should be 0 because x and y are two unknown and independent variables. So we will get, putting dy by dx is equal to 0 here, we get this relation. F dash x by y multiplied by y minus 0 by y square is equal to f dash x, right? Because this term will also vanish, right? So I'll write that in the next page. It is f dash x by y multiplied by 1 by y is equal to, on the other side, we got f dash x, right? This is the differential equation that we are getting. Now here, what I can do, I can use the fact that I know that f of 1 is 0 and f dash 1 is 3. These things we already knew from before. So here there is an f dash term. So let me try to use this. So in order to use this, I will have to put y is equal to x here. So if you put y is equal to x, I get f dash 1 by x is equal to f dash x, right? So f dash 1, this implies f dash 1 is 3. So 3 by x is equal to f dash x. And now this is pretty simple. We integrate it and f of x is be 3 log x plus c, right? After integrating this, you'll get f of x is 3 log x plus c. Now, because f of 1 is 0, we can put f of 1 here is equal to 3 into log 1 is 0 plus c, and c is 0. We get a c is 0 from here, right? And now we have gotten our first function, f of x is equal to 3 log x. So notice how we solved this functional equation. We used the limit condition to get two pieces of information. And after that, we differentiated the functional equation with respect to x and put dy by dx as 0. And from there, we got the remaining things, right? So we know the first function. Now let's solve the second functional equation. So here we had g of x plus y is equal to g of x plus g of y minus xy, right? And we also were given limit of x tends to 0 g of x by x is equal to e square plus 6 by 2e, right? Again, using the same logic as before, this is g of 0 by 0. It cannot be finite. If it is a finite value, this implies that g of 0 is 0, right? So we know g of 0 is 0. And then by L'Hopital's rule, I can write it as g dash x by 1, which implies g dash 0 is equal to this limit, right? So we also get g dash 0 is equal to e square plus 6 by 2e. And that can be simplified as e by 2 plus 3 by e, right? So we are getting g dash 0 value and g of 0 value from this limit condition, right? And now let's focus on here. So if I put x and y as 0, again we'll get g of 0 as 0. So that doesn't help us much. So what I will do next is try to think of the derivative here. So we can do the same method that we did before, differentiate with respect to x and y and put dy by dx as 0, right? But I will show you a different method. You can use the same method as the first one that we did. For f function, what we did, do derivative with respect to d by dx, put dy by dx is equal to 0, and you'll get some sort of a differential equation that you will need to solve, right? But another method can also be done, and you should know that method also. What I will try to find is, in general, what is the derivative? G dash x. G dash x definition is limit of h tends to 0, g of x plus h minus g of x by h, right? This is the limit definition of a derivative. So what we can do here is we can use this condition, g of x plus y is given as this, right? So limit h tends to 0, g of x plus h will become what? G of x plus g of h minus xh minus g of x by h, right? So notice this is becoming limit h tends to 0. G of x gets cancelled and we have g of h minus xh divided by h, right? So this is becoming limit of h tends to 0, g of h by h minus x, right? And this x doesn't even have an h term, so that can come out of the limit, right? So you are getting simply limit of h tends to 0, g of h by h minus x, right? And by the way, we already knew this limit. The question already gave us g of x by x as x tends to 0, right? So we automatically know this value of this limit. So what we are getting is a direct differential equation. G dash x is equal to this minus x, right? So we get g dash x is equal to limit of h tends to 0, g of h by h minus x, which is equal to e by 2 plus 3 by e minus x, right? So we have g dash x is equal to e by 2 plus 3 by e minus x. So now simple, it is integration of this. So it will become e by 2 plus 3 by e times x minus x square by 2 plus some constant, right? And now we will use the information that we have already figured out. We know g of 0 is 0. So that will imply that the constant is 0. So this constant is gone. So g of x function for us is e by 2 plus 3 by e x minus x square by 2. And that is our function. Now, what is left for us to do is to figure out what is the number of solutions of f of x is equal to g of x, right? So our equations are like this. F of x is 3 log x is equal to g of x is e by 2 plus 3 by e x minus x square by 2, right? Now, this is a non-standard equation because this side is logarithmic and this side is a quadratic type of a function, right? The best way to solve such equations is usually by a graph. So let's think about it. 3 log x is equal to e by 2 plus 3 by e x minus x square by 2. And if you think about the graph of this will be a downward parabola. So notice that it passes through 0, 0. It will be a parabola something like this. And the peak of the parabola will come at minus b by 2a. The parabola's vertex will be at x is equal to minus b by 2a, which will be b is this ax square plus bx plus c by 2a, right? Okay. So we will get it at negative of b, which is e by 2 plus 3 by e by 2 into a is minus half. So this is going to be 1. So at x is equal to e by 2 plus 3 by e, you will get the maximum value of this parabola, right? Okay. And the other graph is simply y is equal to 3 log x. So it's a constantly increasing graph, right? So you can first of all notice that y is equal to 3 log x is always increasing function while the parabola starts like this, crosses 0, goes up, comes down. So clearly there will be only a single point of intersection, one point of intersection. The question is not asking for finding the root. The question is asking for finding how many points of intersection there will be. The parabola is going to go down. After that, there is no possibility of any further intersections, right? So there is only one common root or one root to the equation f of x equals g of x, right? If you want to find the root, you will have to sort of guess where this root will be. One possible guess you can try out is x is equal to e. Let's try what is coming here. Left hand side is becoming 3. Right hand side is becoming e by 2 plus 3 by e multiplied by e minus e square by 2. And so notice this is 1 by 2 plus 3. No, it is e square by 2 plus 3 minus e square by 2. So notice that x is equal to e satisfies the equation. So the intersection point happens at x is equal to e. And at that moment, y is equal to 3. So this point is basically E comma 3. That is the point where the two graphs intersect. So that's how we solve this problem. Hopefully you have understood how we solve the functional equation. The key part here is to understand when you are given a condition like that, how to go about solving that functional equation, right? So that's it for this video. I'll see you next time.